that note, I guess we might as well take a look at it. So it's called buildPalindrome. Now, we have looked at some other palindrome challenges before. I think one of the first ones, yeah, this one over here was called check palindrome. And I don't know, should we look at a refresher of how we did this? So there were a few ways that we were able to do this one. I guess at this point I wasn't really archiving all the different methods, but basically for this one, we kind of did a loop. You know, we went through half the string and compared it to the other half. And that was pretty much it. So maybe we'll do something like that. There were other methods we were able to do that, so maybe we'll look at those as well. But in this case, it's not that we're just checking for a palindrome. This one is not called check palindrome. This one is build palindrome. So let's try to figure out what it's asking us. It's saying, if we're given a string, we want to find the shortest possible string that can be achieved by adding characters to the end of the initial string to make it a palindrome. Okay, so basically we're starting out with, pardon me, for example, we're starting out with this one, which is ABCDC. And we want to make that a palindrome. So it's not a palindrome currently. By the way, keep in mind, a palindrome, it's a word or a string that reads the same way left to right or right to left. So if you flip it, it's the same thing. Okay, so that's going to be part of our code here. We are going to want to write a function, something like isPaldindrome. And that's kind of a long name, but it's descriptive, so that's good. Anyway, just to take a look at this example over here, basically, like, there are a number of things we can notice about this. We could say, for example, although the whole thing is not a palindrome, part of it is. This part is. So really, if we can build around this part and just sort of build in the stuff that we're missing. So let me just lower the thickness on that. Yeah, so we just put like the B and the A at the end of that one. Okay, that didn't work as well as I was hoping. But anyway, the point is, we're basically going to take characters from the end here and try to make this thing into a palindrome. Okay, so let's start with this, first of all, our function for checking if something is a palindrome. So the quick way to do this would basically just to say return string is the same as string dot split dot reverse dot join. And if you're wondering why I'm doing the split and the join here, it's because by default a string doesn't have that reverse method. Reverse is something that's for arrays, so we need to convert the string into an array and then reverse it, and then we can join it. So let's see if this is working, first of all, because we've got the function, we've declared it and all that, but we haven't actually used it. So let's try that, taco cat. So that should be a palindrome. We should get true for this one. We are getting true. Okay, and then if we were to pluralize it, now it loses that. So good, that's false. All right, so that seems to be working the way we want it to. There are a few changes we can make. So I've talked about this a few times. I don't really like using dot split if we're trying to convert a string into an array. I usually like to either use array.from, which is sort of like built in for the array object, and that should work just as well. I mean, we're converting it to an array. And the reason I like this a little more is because it makes it a little more clear that we are in fact converting to an array. Nothing about split really implies arrayness if we don't already know. But there's another way to do this too, and it's to use an array literal to begin with, and then we want the string in there, but we don't want an array just containing the string. We want an array containing all the characters of the string. So we can actually just use a spread operator for that, and that's going to break it down into its characters, put that into an array. So that's kind of neat. I think, like, in terms of bytes, this is probably the shortest way to do it, and also I kind of like, I think it's the nicest in terms of converting a string to an array. But anyway, the point is it's still working, so that's good. Okay, so is this the best way to check if something's a palindrome? Well, I don't really think so, to be honest, because like we're converting something to an array just to convert it back to a string later. And I generally have an allergy to that kind of thing. I don't usually like to convert something if I don't have to. You know, if we're not using it as an array at all, I don't really see the sense in converting it to an array. So instead, let's do a loop. We'll say for let I be assigned the value of 0, I is less than str.length divided by 2. And we'll find out why we're dividing by 2 in just a sec. But basically, the idea is what we want to say is, I guess just at the top here, I'll say constant length is going to be str.length, just so we don't have to check each time. And that means I can actually economize a little bit on this because we already know what length is. And then from here, we can just say something like if str at I, if the character of the string at I, actually what we want to say is if it's not equal to the character at length minus I minus 1, then under that circumstance, return false. That means it's not a palindrome. And if we were able to make it through all that without ever having this circumstance happen, without ever having like a mismatched character, then that must mean it's true. Okay, so I kept this up here just to sort of show the comparison. I mean, I realize it's a lot longer, the stuff we have below it, but I'm gonna delete that now, and we're gonna see if this runs, see if this works. So it is saying true that this is a palindrome. We'll try again, pluralizing that, see if that works. It's not saying that's false. Let's try a palindrome that has an even number of characters and see if that's working. So never, odd, or even, for example. Let's try that. Okay, that's good. And what if the two middle characters, for whatever reason, did not match up? Is it still working? False. Okay, great. So that's what we want. All right, so isPaldindrome is working good. Now, in case we're wondering about this, so first of all, I is going from 0 to length divided by 2. The idea is that it doesn't need to go all the way to the end here, because otherwise we're kind of retracing our steps. Like the idea is basically that when we're doing these comparisons, we start by comparing the 0th character, so the A here, to the A over here, the last character. But what would the index of that last character be? Well, what's the length of this thing? So I guess the length of this is 7, right? So in terms of our indices, this one would be 0, 1, 2, 3, 4, 5, and then 6 at the end here. Okay, so basically the index is 6, the length is 7. So we basically want to be doing like, that would be our 7. We're going to subtract the I. In this case, I is 0. So we still have 7. We need to subtract another 1 to get it back down to the 6 that we're looking for. And then as I increases, so like, let's get another color in here, maybe more of a green. And yeah, when we're comparing the B here to the B here, basically the idea is now this has an index of 1, which means this one will have an index of 7, minus 1, so an index of 5, so good, it's working. And then basically the idea is as soon as we reach, well actually the next one, like we compare these C's and then it doesn't really matter what the middle character is. Like the D there, that could be anything. It's not going to stop it from being a palindrome. Essentially it matches with itself. So we don't really need to bother checking that, which is why it's strictly less than length divided by 2. Okay, cool. So I'm glad that's working. isPaldindrome. Let's maybe tighten it up a little bit. Yeah, I just don't want it to take up too much space. Normally I would include those spaces, but I want to be able to see the other stuff that we're going to add to this. Okay, so here's the way I want to go through this. I want to basically build up an end part. Okay, so end part is going to start as just an empty string. Because you know what? We might be starting with something that's a palindrome already. Right? Like this one. That's already a palindrome. We don't need to actually add anything to that. So that's why I'm starting this as an empty string, because this is going to be the thing that we're adding on. And in fact, this is what we're going to return at the end. Just something like that. String, so the original string, plus end part. Or, okay, when I say plus, keep in mind, I'm talking about the concatenating plus, not the addition plus, it's concatenating. So it's putting those two strings together. Okay, so now what do we want to do? Well, okay, we basically want to be adding on to this. So I'll say for let I is assigned the value of 0, and while I is less than the string length, and then I plus plus. So we'll do a loop on this thing. And what do we want to be doing in this loop? Well, basically we want to say if the string plus the end part, if it's a palindrome. So if is palindrome string plus end part. Okay, now before we go any further, well, actually, okay, we will go a little bit further. So if that's the case, if it's already a palindrome, break, get right out of here. And otherwise, we'll just append something on the end part. So we'll do end part plus equals, I guess the character at index I. We could probably use a for of loop, but we'll look at that later. So we'll just say st at I. Okay, and we'll clean that up a little bit. So what I was saying earlier is this is the beauty of writing our function name like this, like as isPaldindrome, instead of something else like f or something equally non-descriptive as that. So the reason I like this is because now it almost reads like a sentence. If isPaldindrome this thing, then break. It's easier to read that way. So anyway, I think that's cool. I like that. I hope you like it too. Anyway, the point is, so what we're doing here is we're basically saying we've got this end part. It starts out, it's nothing, right? We're not adding anything onto the end. And then as we go through it, so we're going to go through each character starting from the beginning, and we're going to try appending it onto the end. And we're basically going to say, okay, well, if you get to a point where that thing is a palindrome, where what you've got is a palindrome, well, stop. You don't need to go any further. You don't need to continue iterating through end part here. Break the loop. Keep in mind, break means like we're done. We're not going to get to this part here, and we're not going to get to any other iterations. This no longer matters if you see break. It just says get out of that loop. Okay, as opposed to continue. If I had said continue instead of break, then it would have said, okay, well, we're done for this. We'll ignore this stuff down below, but we will continue to respect this, and we will increment I and see if it's still less than string.length. Okay, so if we don't get to the break here, so if we haven't already reached a palindrome, then we're going to say, all right, we need to add a little more onto the end part. We need to concatenate some more characters, or one more character anyway, one at a time, onto the end part. So let's see how that's running. If we run this, we find not so good. Yeah, not so good. And the reason is because, check this out. We have this original string, A, B, C, D, C. And then that same string again, A, B, C, D, C. So the problem here is that I'm saying end part plus equals this, end part. I'm saying it plus equals st at I, which is the same as saying end part is assigned the value of end part plus st at I. Oh, hey, Zuzak. How's it going? So this is not quite what we want, because it's basically saying we're adding on that extra character to the right of end part. But really, if you think about it, like we have A, then we have B, then we have C. As we're going through this, the thing we want to add on, in this case, would actually be A. So we should be looking at this in the opposite order. So really what we should be saying is that end part is assigned the value of st at I plus end part. That's, it's the reverse. Now, I don't think we can do that in such a way that's like as compact as this thing up top. So we'll just delete that for now, and we'll see if that's going to run a little better. And it is. Okay, cool. So that's nice, right? But I'm realizing something now. It seems like I'm only using this index right here. So instead of doing this whole I business, this whole index business, why not just do something like character of string? And then I don't need to do any of this. I can just say character. Let's try that. See if that works. Ooh, it works, and I have to say I like that a lot better. Okay, cool. So should we try submitting this? Let's see if it passes all the hidden tests. Let's give that a try. Ooh, and it does. Okay, so that's nice. That's always a great feeling. Yeah, that's good. We've passed it. We've completed all the tests. This works. I think it's pretty good code, but I do have a couple beefs with it. So the main thing is, like, all right, check it out. This isPaldindrome function. It's got a for loop in it, right? It's basically going through half the length of the string that we give it. The string that we give it is something that's continuously growing, right, in this other loop. So we're looping across the string, and then within that loop, we're doing another for loop on something that's getting bigger and bigger and bigger. And so I feel like we're doing a lot of these. And I feel like we're probably repeating ourselves a little bit. We're probably doing the same calculations, or more calculations anyway, than we need to. Now, none of this is going to be that big of a deal, because if we look at our guaranteed constraints, and that's why I switched back over to the description here, look at this. The length of this thing, it goes from 3 to 10. That's nothing. Like, when we're considering stuff like computation time, time complexity, efficiency, that kind of stuff, we're talking about more like if the length is 100,000 or a million or something like that. Like, how are you going to deal with that? How are you going to optimize it? So even though that's not the case here, I kind of want to be prepared for the case where it might be that way. So what we're going to do for this next one is we're going to rethink this a little bit. So we'll use parts of this, but for now we're going to wrap this up, and yeah, we'll just leave that archived for now. The thing I do want to use is this. So our function is palindrome, because we're still going to be interested in that. And like, I don't mind that this has a loop in it. It's just maybe we don't need to be checking it every single time. You know, maybe there are some situations where it's just, you know, not going to be necessary. So how else could we do this then? Well, we could do the sort of thing where maybe we're like, let's see. Okay, well, we'll do something similar where we've got an end part on the end, and it'll start out as, I don't know, something, you know, empty, I guess, just like what we had before. We'll do something like this, plus end part. But how is this going to be different from what we had before? Well, basically what we're going to do is, the way we're going to iterate through this is the part that's going to be, I guess, a little bit different. So here's what we're going to do differently. Basically we'll say for let I is on the value 0, I is less than st.length, I plus plus. We're going to do this. So we'll say, let's do this for now. Let character be st at I, and let end character be st at st dot length -1. So basically the last character. And maybe I should call it that. Last character. Yeah, that's better. Partly just because it's more descriptive, and partly because I don't want to have a situation where when I'm typing end, I'm getting suggestions for end part and also end character, because then it just, you know, it's more typing that has to be done. Anyway, so, okay, we've got these two parts here, and basically what I want to say is the only circumstance under which I want to check if this thing is going to be, well, okay, sorry, I should be a little more descriptive about what the goal is here. The first thing I kind of pointed out here is that part of this thing was already a palindrome. So like we've got A, B, C, D, C. The CDC part of this, it was already a palindrome. So that's kind of the way I want to check this now. I want to go through it and I want to say, well, is any part of this already a palindrome? And if it is, then just take that part at the beginning, flip it around, put it at the end. That's basically it. Okay, so great. That's, yeah, that sounds good. So let's do that. So basically, we've got our character, we've got our last character, and what I want to say is if the character is the same as the last character, then under that circumstance, we want to check if that, you know, slice of it is going to be a palindrome. So we'll say if is palindrome, and it's going to be st.slice I. Okay, so what are we talking about here? Well, st.slice I. We've looked at slice before. Let's actually just return that for now. So st.slice at, let's say 2. Okay. We'll see what that's going to return. Hopefully, yeah, that should work for all these because they're all at least length 3. So they should always have a character at index 2. And it's taking a while to run that. I don't know if it's because I have some sort of error in here or if it's just like high traffic time, but, okay, yeah, I do have a syntax error. It's on line 21. What am I doing? Oh, yeah, I've got an if with nothing after it. Here, let's just do that for now. So, okay, this is the thing I'm interested in. I just want to make sure that we all understand how this slice thing is working. Basically, the idea is it's taking a part of the string. So in this case, it's taking the CDC. Now slice can have other arguments in it, and basically the way it's going to work is that it's going to return the part of the string that begins at index 2 in this case, or whatever you have here, and it's going to end just before this index. Okay, so it's just the C and the D in this case, and the next one is just going to be the A and the B. Starts at index 2, ends before index 4. Now, if I don't put that second argument in there, then it's just going to start at index 2 and take everything from there. So basically from here to the end of the string. And that's really what we're looking for, because we want a palindrome that's going to end at the end of the string so that we just have to add on the stuff that's the reverse of the thing that isn't a palindrome. Okay, so that's why we're doing slice at I, because that's the index where we believe it might be a palindrome. And the reason I say we believe it might be a palindrome is because we're saying, well, the character we're at now is the same as the last character. So in terms of how this is working, we're going through the string and we're saying, okay, this first character here, A, is that the same as the last character, C? Oh, no, it's not. Okay, well, in that case, let's start building up our end part like we were doing before. So say end part is going to be character plus end part. Okay. So now A is end part, or end part is just the string A. All right, and then we look at the B and we say, hey, is that the same as the C over here? No, it's not. So now end part is going to be B, A, because we're putting on the character first and then whatever end part is. Okay, and then after that, we're saying, all right, what about the next character, the C? Is that the same as the C over here? Oh, yeah, you know what? It is. So we'll say, okay, well, is this thing a palindrome? And if so, what are we going to do? We're going to break. We're going to say, oh, well, great, we found it. Yeah, awesome. So the thing is, basically what we were doing before is we were just checking if it was a palindrome every time. Now what we're saying is we're going to use this last character. In fact, you know what? We're not changing that, so we might as well just put that over here and make it a constant. Const, last character is going to be that. Okay, and then let's see. Can we run the tests on that? Is that going to work? No, it's not working. We're just getting the CDC here. So why is that? So end part is not working here. Or wait. Oh my God. Okay, so it's because of this, and this is a great teachable moment here, I guess, for me. But anyway, the point is, anything that happens after a return is just not going to get executed. Return basically means, okay, we're ending the function there, we're not looking at anything else after that. So I probably shouldn't have a return in there because I do want it to execute the rest of the code here. So sorry about that. Let's try this now and we'll see what we're getting. And while we wait for that to load up, something I'm noticing is, again, we're not really using the index here aside from just this. Oh, actually my mistake. I was about to say we could just do another for of loop like we did down here where we just said let character of st. But we can't do that here, and the reason is because of the slice. That's like, we need the index to know where to slice this thing. So I do want to actually use this more kind of old school style of for loop where we're actually looking at the index and then from there getting the character. And look at that, it's passing all the tests just in time. And let's see, is there anything else we're going to do? Well, okay, I'm just going to clean this up just a little bit. And in fact, I suppose what we could do, because like, look, we've got an if, and then the only thing inside of that is another if. So I suppose we could do something like this, and then I think I've got an extra bracket. Yeah, okay. Oops. Did I? Oh no. Okay, I did have the right number of parentheses there. It's this I probably want to get rid of. Okay, great. So let's run that. Let's see if that still works. And you might be looking at this and thinking, oh, okay, but hold on a sec. that's just as inefficient as it was before, right? Because now your if statement has the isPaldindrome in it. Isn't it checking that every time now again? And I know it looks that way, but I don't think it is. And the reason I'm saying that is because the way these Booleans work in JavaScript anyway, is that for an and statement like this, well, keep in mind, under what circumstances is an and statement true? So let's look at that real quick and let's do a very brief refresher on that. So let's say we've got A, we've got B, and we've got A, and B. Well, that's quite atrocious. Sorry about that. But anyway, what possibilities do we have? Well, A could be true or A could be false. And same with B. It could be true or false. Or true or false. Okay, so these are all the possibilities. Either they're both true, A is true, B is false, A is false, B is true, or they're both false. And for this to be true, they have to both be true. So that's the only circumstance under which they're both going to be true. All these other ones, it's going to be false, false, false. Okay, so why are we bothering with this? Well, it's basically because of this over here. We're using this and thing, right? So we're using that, and the only circumstance under which this is going to be true is if they are both true. Okay, so let's think about how this is going to work then. Let's say that that this part is false. Okay, so table might look nicer. Oh yeah, like if I were to type it out. Yeah, oh, that's almost a guarantee. Yeah, it would almost certainly look nicer in here. But oh well, I'm committed to this now, so we'll deal with it. Anyway, the point is, okay, so let's say this part over here ended up being false. Well, it's going to say, well, okay, there are two possibilities. If the first one is false, then maybe the second one is true, or maybe the second one is false. But no matter what, we're going to get false. So from the point of view of the interpreter here, it's saying if character is last character, it checks that and it says, oh, that's false. Well, if that part's false, I kind of already know the conclusion here. I know that this whole thing is going to be false, so I don't need to go any further. I know I'm not going to execute this if. We're not going to break. We're going to move on to the next one. So basically, if it knows this is false, it's not going to execute this part. And I've seen people use that behavior in like really clever, sneaky ways in order to have some code that's only going to execute under certain circumstances. But anyway, point is, so if the first part is false, the whole thing's going to be false. It's not going to get to the break. If the first part is true, then yeah, we do need to check this thing. And maybe it's true, maybe it's false, but that's the point of it, right? We only want to execute this function if the first part is definitely true. Okay, so just wanted to comment on sort of the subtleties of that, the stuff that might not be obvious. But let's see if this is actually passing the hidden tests and everything. And yeah, it is. Okay, so that's good. That's real nice. Okay. So now I'm thinking about this and I'm thinking it's good that we were able to get an algorithm that's slightly better than the one below. It's a little more efficient in the sense that even though we've got a bit more code, we've got more stuff that we're checking here, ultimately that's going to save us because I think it's a lot easier to check if one character is equal to another than it is to actually execute this whole isPaldindrome code every time. So it's saving us some effort here. It's saving us some computation time. And again, it's not going to make much of a difference if the string is only length 10, but if it was 10 million or something like that, then yeah, it would make a huge difference. So we do need to consider those things. The thing is, I'm wondering, is there a way we can do this? Is there a way we can answer this problem without actually building this function, without actually having an isPaldindrome function? And I had to think about this for a while, but as it turns out, yeah, there's a way. So check it out. I'm going to start with something called flipped, and it's just going to be what we saw before. So just the reverse of this. I don't want to forget that. Okay, so we're just creating an array from the string, we're reversing that array, and then we're joining it back into a string. Now, of course, there are other ways we could do this. We could use a loop or something like that. I'm just going to do this for now. If anyone wants to see another strategy, let me know. We can do that. And then I'm going to say let offset be assigned the value of 0. So what's offset? All right, well, here's how we're going to do this one. Yeah, here's how we're going to do this one. We'll go over to this other whiteboard, and let's take a look at a word. We'll start with a word, and the word we're going to start with is taco. And what are we going to do with this? Well, if we look at our code so far, there's not much here. We've got this thing flipped. So let's see what flipped is going to look like. It's going to look like this. It's taco backwards. Okay. And then what are we doing with this? Well, I've got this offset thing, and it starts at 0. So what I'm doing with offset is basically I'm offsetting these. So right now, if the offset is 0, I'm sort of comparing these characters, and I'm finding they don't match up. So I'm going to increase the offset. So I'm going to move this over a little bit, and now I'm going to compare these characters. I'm going to see if these are lining up. And no, those are not lining up. Okay, so I need to increase the offset again, and they're still not lining up. The C and the O, they're not the same. So then finally, we'll do one more for the offset. And we find now the O here is the same as the O here, and there isn't anything else, so we'll end it there, and we'll say, okay, so basically at the end, we'll just return this part of the original string, everything up to the offset, and then we'll concatenate this part onto the end of it. So finally, our result in the end is going to be the TAC from the original and the OCAT from the other part over here, Taco Cat. Okay, thing is, it might be a different example. So, well, yeah, I guess that's kind of obvious. But anyway, specifically, the example might be something where the overlap is going to be a little greater. So the example we were working with before was, what was it, ABCDC, I think? I think that was it. Ugh. ABCDC. So as you can see, I'm still getting used to this new mouse. It's a bit of a learning curve, but you know, we're getting there. Was that the right string? ABCDC, cool. So we're gonna start with an offset of 0, and well, okay, I guess we should reverse this thing. So it would be C, D, C, B, A. I hope I did that right. Yeah, I think that looks good. Okay, so we compare these, we say, no, not the same. That's enough, we'll move on. Okay, so we'll increase the offset. C, D, C, B, A. Okay, again, these are not the same, so that's enough. We're gonna increment. C, D, Z, B, A, and now here's where things get interesting, because if we're comparing these, we can say this C is the same as this C, this D is the same as this D, this C is the same as this C, and then there's nothing else in the string here, so we're done with that. So we say, oh, okay, great. So from here, we're going to be taking this part of the original string, just the part up to and not including the offset, and then this part of the additional bit. Okay, so then basically we get A, B, C, D, C, B, A. Okay, cool. And is that what we were looking for? A, B, C, D, C, B, A? Yeah, it is. Okay, cool. So that's basically our plan. We're going to flip the string right off the bat. We're going to start with an offset of 0, and then we're just going to increase that offset until we find that the strings are overlapping. Well, actually, sorry. What I mean is in the overlapping part of the strings, everything is going to be the exact same. So let's do that. So basically, offset is starting at 0, and I'm going to do a for loop. Now, okay. Originally, I was thinking about doing it this way for let offset be assigned the value of 0. Offset is less than string.length, offset plus plus. And the reason I'm not going to put the let in here is because the end of this is going to be something that involves the offset. Because remember, we're going to do a slice on this. We're just going to look at the part up to and not including the offset. And we're going to concatenate on that the flipped part. That's what we're going to be doing at the end. So because we need offset outside of the scope of this block, we don't want to be declaring it using this block scoping strategy in here. So we're actually just going to leave that first part blank for now, and then we'll use it later. Okay, so what are we going to do here? Well, this is basically where we're looking at all of these. Like, so these would be sort of the results of this offset loop. And so for the offset loop, basically what we want to do is a smaller loop within, and that loop is going to be like this here, where we compare each of the characters. So like, you know, are these equal? Are these equal? Are these equal? So that's basically the idea. And we'll break as soon as we can. That's kind of a theme in this one, I guess. But basically the idea is, like, for example, right off the bat, is the C and the A the same? No, they're not? Okay, well in that case, don't bother comparing all the rest of them, because we know it's not going to work. So that's another just little like micro optimization strategy if you want to make your code just, you know, that little bit faster. And that's not going to change like our time complexity. It's not going to make the difference between being like, you know, big O of n squared and big O of n or something like that. But it's enough that it might make the difference between passing the hidden test and not passing it. In this case, we're going to pass the hidden test as long as our algorithm is, you know, working, as long as it's logically sound. What I'm trying to say is we're not going to time out for strings that are that small. Okay, so basically our strategy is to do something like this, where we're going to say for let I be assigned the value 0, I is less than flip.length I plus plus. And we want to say, well, if flip.I is not the same as st at I plus offset, okay, so that's really important, then in that case, we're going to break. We're going to say, no, not going to work. Okay, so I'm going to actually make a comment here. Not going to work. All right, so let's deconstruct this a little bit, and I'm actually going to have to make one modification. So flip.I is not equal to string at I plus offset. So why the I plus offset? Well, keep in mind, flip.I. So flipped is this part, right? So I is going to start at 0. We're going to say this one, then this one, then this one, then this one. But we don't want to be comparing the C to the A here. We want to be comparing it to the C over here. So we need to move over 2 characters. Well, that's what the offset is. So we're adding the offset to the thing that we're comparing. The thing is, we don't want to get to a point where we're starting to compare like the B here to some non-existent characters at the end of this one. So because of that, we actually want to say, well, as long as I plus offset actually is less than flip.length. And actually, I'm going to say less than st.length. They are the same. But the reason I want to do it that way is because it's the st that would cause a problem if its index here, I plus offset, is greater than or equal to its own length. Okay, so the thing is here, like we've got a loop within a loop. I want to break out of this one, but then I also want to tell this outer loop, like, you know, whether or not we found it. And in this case, this is where we haven't found it. So this is kind of like, you know, remember, down here, basically, for my isPaldindrome code here, we basically said, well, if this happens, then return false. And if we can make it through the whole thing without that happening, well, then return true. So here we want to do a similar kind of thing, but we're not doing a return because this isn't inside of a function. So we'll say, well, if this isn't going to work, you know, if this at any point ends up being the case, then it's not going to work. So we basically want to say, you know, return false. And if we get to the end, return true. But we're not going to use actually return. Instead, what we're going to do is we're going to do a variable, and it's going to be called, it's going to be something that sums up the idea that this one has a possibility of being the right answer. So I'm going to call it could be the one. And we're going to use sort of innocent until proven guilty strategy here. So we'll say could be the one starts as true, but as soon as we find that there's a mismatch here, well, no, you can't be the one anymore. So it could be the one ends up being false. And then if we get to the end and it turns out this could be the one and it made it through the whole thing, well, then just break. Don't go any further. Don't increase the offset. We found the right one. We could even at this point just do our return statement right here. That's interesting. But anyway, let's try running this first of all. Oh, yeah. And is it passing the hidden test? Let's find out. Oh, yeah, it is. Okay, great. So now I'm actually inspired by that thing we were just thinking about. So let's get this into the loop. And then instead of just breaking here, let's do our return here. So we'll say return, and we'll just do this. Is that going to work? Yeah, that's going to work. Well, that's probably a bit better, I think, eh? Because, like, the thing is, it's going to find one eventually. You know? Like, because you might be looking at this and thinking, well, what if it makes it through this whole loop and it never finds one? But it's going to find one eventually. Because eventually, the offset is going to be great enough that it would just put the flipped string, like, right onto the end of the other one. So, eventually it's going to work. Eventually it's going to be a palindrome. Okay, so I think that's pretty cool. I really like this one, actually. I like the fact that we're not using like an isPaldindrome function to actually do these checks here. We're just, well, we're doing this basically. This is probably the most visual, succinct way for me to summarize that. So I think that's kind of cool. I mean, my only, I guess, beef with it is this. Like, there's probably a better way we could do that. Well, there's definitely a better way we could do that. So we could say something like, you know, flipped is going to start out as this empty string, and then for let character of string flipped is assigned the value of character plus flipped. Whoops. Relying too much on my autocomplete there. Does that work? No, it doesn't. Assignment to constant variable. Oh, yeah, that's true. I should make that a let. All right, so let flipped be that, and there we go. So, is that better? Well, yeah, I like it a little better. It's more writing, but that's fine. Okay, so Zuzak is asking, would it break with an empty string? Okay, so basically you're wondering, like, if this st thing here was empty. Actually, you know what? That's a really good point. So let's try that. Let's just say st going to be an empty string. Now, first of all, what do you think? Is it going to break? And just to clarify, when you say break, do you mean like break the function, like, you know, have an error or something like that, or do you mean break as in like this break, like that over there? Because like the way I'm looking at this is it's saying while offset is less than the string.length, so like it, you know, that's not even going to be true even when offset is 0, because the length of this thing is 0. So not only is it not going to break from this loop, it's not even going to enter this loop. So it probably won't return anything, you know, like it would return null basically. So if we run this now, I'm expecting we're going to get a bunch of nulls. Yeah, we're getting nulls. The thing is, I'm not actually worried about that. And the reason is because if we pay attention to our guaranteed constraints, it has to be at least length 3. So we're not actually going to have an empty string for st. So hopefully that answers your question. I mean, more generally, what I would say is if this was actually like, if we were using this function in production, if we actually wanted to, you know, use this in like a web app or something like that, then yeah, we should probably check just in case and like throw an error if it's an empty string or if it's less than the expected length or something like that. But I'm just going to rely on the guaranteed constraints for this one. Okay, so I guess that's it for this one. Yeah, we'll wrap it up there. I think it's passing, right? If we, yeah, that's passing. Okay, so let me know if you have any questions, comments, or concerns. You know, leave a comment in the video or something like that. You can reach me on Twitter or on Facebook as well, or on codefights.com. Just look out for ZeroCool. And in fact, actually, yeah. So we're done with this one. Let's finish that up. So if you do want to find me, I don't add any code friends on this account just because, you know, I don't want chat pop-ups, and I don't want to reveal like how far along any of my friends are on stream. So if you want to be friends, this is the account to look for. Zero cool. So just look for the cat. Okay, so we're gonna wrap it up there.